Hello everyone, in this lesson we're going to be talking about slope, or the rate of change. So slope is a measure of the steepness of a graph. It is the ratio of the rise divided by the run of a line. And we'll talk more about what we mean by rise and run in just a second. For a linear function, the slope is a constant rate of change. And I know that could seem a little bit of an oxymoron. Constant and change are both in that same phrase. Well, what that means is that, yes, we are looking at data that's changing, but every time it is changing by the same amount, so hence a constant rate of change. It is sometimes also referred to as the constant of proportionality. Sorry, not enough room here. Proportionality. Or sometimes simply the rate of change. And it is represented by the letter M. So if we look at these four pictures represent four different types of slope. So in graphs, just kind of like in English, we read from left to right. So if we look at these graphs from left to right, this one starts here and ends here. So as we go from left to right, this graph, the line, goes up. So since it goes up from left to right, we would say this is a positive slope. Similarly, this one from left to right is going down. So it is a negative slope. Now what happens if from left to right we're not going up or down? Well, what's right in between up and down? Zero. So this has a zero slope. Now the trickiest situation is when from left to right it doesn't go left or right at all, but it does go up and down. So we'll talk more about why this is the case, but since we can't really describe this numerically, we would say that the slope is undefined. Okay, now we do want to find numerical values for most slopes. So let's first look at the case where we have a graph. So we want to find 2 points on the line with integer coordinates. So if I look at the graph, what we're really talking about is, for instance, here, or here, or here, or here. Let's see, is there another one? Yes, one more. There's all these places with integer coordinates. Basically, it's 2 points on grid lines. So we can pick any of them, but we always want to start with the furthest left and go from there. So if we look at, let's pick this point here and this point there, how much do we change by? So first we're going to look at the vertical distance. So from this point going left to right, we go up 1, 2, 3, 4. So we went up 4 times, and that would be the rise. And then we want to talk about how much does it go over, which we could call the run. And this time it goes over 2. And so this is where we get that the slope is the rise over the run. Another way we might describe that as the change in y, which is the vertical change, over the change in x. So in this instance, m is 4, change in y, or the rise, over the run, 2. So we would say that the slope is 2. And yes, we should simplify all the time. So this has a slope of 2. Let's look at just a few more examples. So if we look at this one here, let's find 2 places where it crosses, here, and we'll pick again here. Any of them would work, like this point in the middle here would work as well, but let me just pick 2. So the rise, 1, 2, 3, 4. 1, 2. We picked the same slope again. We still went up 4 and over 2. So our slope is 4 over 2, which is 2. Let's look at something that does a slight different direction. So here, I can see clearly this is one point where it crosses. The next one's a little hard to find, but it is right up here at the top. So this one goes 1, 2, 3, 4, 5, 6, 7. But as we're going left to right, we had to go down to get to the next point. So we'll call that negative 7. It does still go over positive 1 for the run. So the slope is negative 7 over 1. Or what we should better say is just the slope is negative 7. Now, you might notice from our different types what's happening here, but if you didn't, you can think, well, how much does it go up and down from this point to the next? Well, it goes up 0, but it goes over 2. Well, 0 divided by 2 is 0, and so that is our slope. And that'll be the case for any horizontal line. When we have a vertical line, pick any 2 points, and pick one down here and one way up here if we want. It does have a up and down distance, but it doesn't have a left or right distance. For between these ones, it goes 1, 2, 3, 4, 5, 6, 7 up. And how much over? None. Well, 7 divided by 0, you should know by now, you can't do that. That is undefined. But in general, all vertical lines will be undefined slopes. So that is slope from a graph. Next, we have slope from 2 coordinates. So we still want the rise and the run. The y coordinates will provide us with the rise, and the x coordinates will provide us with the run. So if we called the first point x1 and y1, and the second point x2 and y2, and those little subscripts, those 1s and 2s, that's not an exponent. It doesn't mean square it or take it to the first power. Those are just descriptors. This is the first x, this is the second x. This is the first y, this is the second y. We can take that and use a little equation to help us find the slope. So slope m is equal to y2 minus y1, the difference between the y's, over x2 minus x1. Remember, we did rise over run before, so that's why we're sticking with y's on top over x's. So let's look at an example to see exactly how that's going to work for us. All right, for this first one, let's start by writing down the formula. M equals y2 minus y1 over x2 minus x1. Now, it might be helpful to just go ahead right at the beginning and label the 4 numbers here. So I'm going to call this x1 and y1. They came from the same point, the first ones. And x2 and y2, they're the second points. If you do that, then it's easy to just plug the numbers in. So y2 would be 3, y1 would be 17. On the bottom, x2 is 4. Now, be careful. The formula has a minus in it. But then x1 is negative 16. So we've got minus a negative here. So we can go ahead and subtract this, and we get negative 14 up top. On the bottom, you should know that that's going to be really 4 plus 16, so we have 20 on the bottom. So our slope is negative 14 over 20, which we can simplify, yes, you should simplify, as negative 7 over 10. And if we wanted to think, well, how does that make sense? What does that mean? If we had a graph, and I'm not even making an accurate graph, I'm just going to make it points in space. If we had our first point here, how do we get to our second point? This is our rise, and this is our run. So we would go down 1, 2, 3, 4, 5, oh, geez Louise. 1, 2, 3, 4, 5, 6, 7, and then we'd go over 10. I'm just going to call that 10. So here's our next point. We went down 7 over 10. This would be the line that did that. It was a rise of down 7 and a run of 10. That's what these 2 points created. Okay, now there's some special cases that might pop up on you, like if we look at number 16. When you start this, you're like, okay, m equals y2 minus y1 over x2 minus x1. All right, now you can pick whichever point you want to be the second point. So like maybe this time I want to call this x2 and y2 and this x1 and y1. That's fine. You just got to be consistent. So if I look at the y values, if I call this y2, okay, that's negative 5 minus this y value, negative 5. Now I have to start with the positive 17 because that was where I started for y. So 17 minus negative 17. All right, so both places I get this minus a negative that turns into a plus. On the top, negative 5 plus 5 is 0. On the bottom, 17 plus 17 is 34. 0 over 34, that means the slope is just 0. Wow, that's unusual, but don't hate on 0. 0 is a fine number. Could we have recognized this even faster, though? Look, the y values are the same number, which means that if we did graph this, we would be, one would be like negative 17 over there, positive 17 over there, but they'd have the same y value. They would be a horizontal line. So if you see that the y values are the same, you know you have a horizontal line and a slope of 0. Well, what happens if we look at a situation like 21 here? So in 21, we start and we're like, m equals y2 minus y1. See how I'm writing it every time? You can do that too. I believe in you. All right, so we go ahead and we subtract our y values. So I'm going to say negative 6 is our first y value, minus negative 4 is our second y value, over negative 2 here, minus negative 2 here. All right, numerator, that's a plus there. So negative 6 plus 4 is negative 2. Denominator, negative 2 plus 2. Ooh, that's 0. What's negative 2 divided by 0? Oh, I can't do that. Ah, the slope is undefined. Now, you could do the work, get here, division by 0, and conclude undefined. You could also recognize, same x value. So if we were to plot these 2 points, all right, so they're both over at negative 2, and one is at negative 4, and one's at negative 6, but these are in a vertical line. So if you see points with the same x value, you should know that the slope will be undefined. Great. All right, so we did finding the slope from 2 points. What happens if we have the slope, but we don't quite have the 2 points? Look at this point here. It is missing one of its values. It's missing one of its y values. Well, we know our formula is m equals y2 minus y1 over x2 minus x1. In this case, it might be really helpful to label x1, y1, x2, y2. All right, so we can plug everything that we know in. Our slope even, negative 8 over 5 is equal to, okay, y2, that's x, which is weird that y2 is an x, minus y1 is negative 8, and x2, 3 minus 8. Okay, let's simplify as much as we can. We see that, now remember, it's like a whole equation, so we can't like drop this side and just start working on the other side. We have to take them all together. So negative 8 over 5 is equal to, can't really do much on the top other than make it x plus 8, but on the bottom, we can make that negative 5. Now, these fractions are making things a little messy. I'd like to get rid of them. So we can multiply by the least common denominator. Now, we can multiply by 5 or negative 5. I'm going to choose to multiply by negative 5 on both sides. On this side, the 5 will cancel, and because it's a negative times a negative, we'll get a positive 8. On this side, the negative 5s will just cancel, and we get x plus 8. So, subtracting 8, you can probably already tell where we're going here, 0 equals x. 0 was the missing number. And I know some of you are like, oh, it was 0? I should have known that all along. Well, don't worry, it's still another number. Sometimes it won't be 0. But we were able to find that value by making an equation here and then solving. Now, when we have an example like 32 here, first of all, the slope is a whole number, or an integer. And so when we go to put that into our formula, m equals y2 minus y1 over x2 minus x1. We put in our negative 3. Okay, so I'm going to put in my y values. This time I have both y values. 0 minus negative 6 over x minus negative 6 again. So let's clean that up. That's negative 3 equals, on top, it's just 6. On the bottom, x plus 6. So it's not as easy to multiply by this denominator, but we're kind of going to do that, because if we look at this as negative 3 over 1, what we could do here is find the cross products. We know that the cross products of a proportion are equal. So we have 6 times 1 is 6. In the other direction, I'm going to write it out without distributing, just so you recognize that we do need to distribute. Oops, that's a negative 3. So negative 3 from this numerator times the whole quantity of x plus 6. We do have to distribute. So when we distribute, we get negative 3x minus 18. All right, we add 18 to both sides. we get 24 equals negative 3x. Let's put that over here, 24 equals negative 3x. And we divide by negative 3, divide by negative 3, we get negative 8 equals x. That's the missing number there. A little bit different when the missing piece of the coordinate is in the x spot. Okay, let's move away from 2 points, but still sticking with slope. We're now trying to find the slope from a table. Remember, for horizontal tables, x is the first row. For vertical tables, x is the first column. So even if they hadn't chosen x and y as their variables, if they chose m and n, a and b, it's always going to be that the x, the independent variable, is in the first row or first column. We're still going to find the differences between pairs of x and pairs of y values. So for linear functions, the change in y divided by the change in x should be constant. Let's dive in on this example here. So we're looking for changes in x. So okay, from here to here, what did we change by? We went up 2. On the y's, we went down 6. Okay. Next time we went up 3. Next time we went down 9. Next time we went up 4 and down 12. Finally, up 2 and down 6. So I thought we were looking for constant rates of change. Well, we are, and let's actually take a deeper look at this. The first time we had a change of 2 for x, and a change of negative 6 for y. So if we think about rise over run, y over x, we had negative 6 over 2. Well, negative 6 over 2 is negative 3. If we then look at the next time, we had 3 over negative 9. So, negative 9 over 3, excuse me. That is still negative 3. Then we could say, what happens when we have 4 over negative 12 over 4? That once again is negative 3, and the last time, negative 6 over 2 again, we also get negative 3. So even though from row to row we had different changes, when we compare them to the y values, the change was constant. It was always changing down 3 for every x that it changed. So this is a constant rate, so the slope here is negative 3. You need to be getting the same slope every time. So let's go ahead and just look at one more that might be fun. Let's go ahead and look at 45, because I know that's already scaring you when you see that one. All right, we went up by 1 for y. We went up by 0.1. We went up by 0.1 again, and we went up by 1 again. Went up by 0.1, went up by 1 again. Oh, decimals, this is the worst. Well, what's the change in y? Every time it's 1 over 0.1. Don't want to leave it like that. 0.1. Well, some of you might need to do this, some of you might not. But if we multiply it by 10 over 10, we can find an equivalent fraction. So this would be 10 over 1. Oh, that's it. The slope is 10. So not too scary. So every time look for the change in y and the change in x. They should be in the same ratio, and that's going to be your slope. All right, now we've moved into words, everyone's favorite. So the slope of a function is the repeated and constant change, or what we might call the rate. So when analyzing word problems, we're going to look for keywords to signal that we are talking about the slope. So near the numbers of a word problem, we want to look for things like each time this happens, or every time this happens, or per, 5 of these per this. Those are all going to be keys that we're looking for something that's happening repeatedly, which is going to be an indication of the slope. You might also see something like, daily or monthly. Those might be also words that key you in on slope. Now, there's probably going to be other numbers in a lot of our problems, but sometimes these are going to refer to things that only happen once. And so these could be things like a flat fee, or amount. They might be an initial amount. They might be something that's just kind of like plus this, something that's added on. They might actually just say the words like one time. So you're going to look for this and many other keywords that would be kind of indicating that something's only happening once. The slope might only be found by recognizing 2 points provided in the problem. We'll look and see what that might look like. So let's look at this first example. We're finding the slope. Labina decides to build websites for local businesses to raise money for her college tuition. She charges businesses $300 for a basic website and $100 for each additional sub-page the business wants. All right, so we've got two numbers, 300, 100. We're going to look around them for any keywords, and when we do that, we see $100 for each. So every time they add an additional sub-page, they add $100. So that's happening over and over. The $300 for the basic website, that's just the basic website. It hasn't changed, it's just $300. So of these two, which one happens repeatedly? Which one is the slope? That's going to be the $100. So M is 100. Now, if we look at a problem like 51, here it says Logan is shopping for a privacy fence to put around his property to block the unsightly weeds his neighbors allow to run wild in their yard. At Quick Fence, 110 feet of fencing sell for $1,375, and 165 feet of fence sell for $2,062.50. So they didn't give us that each or every or per kind of information, but they told us two kind of moments in time. So if we give our pieces of information here to variables, let's say that feet of fencing is X and money is Y, we could turn this first situation into an ordered pair, 110 with $1,375. And we could turn the second one, 165, comma, $2,062.50 as a second point. So now that we have that, we can use our formula M equals Y2 minus Y1 over X2 minus X1. Okay, so we'll plug things in here. We'll get M equals 2062.50 minus 1375 over 165 minus 110. All right. Perfect. There we go. So let's clear this out here. So we've got 2062.5 minus 1375 equals. So we've got 687 here. Let's see if I can squeeze that in there. 687.5. The bottom I can see is going to be just 55. So we could leave it as that, but we really want to try to find a more meaningful number. So if we actually go and do 687.5 divided by the 55, we get 12.5. So we actually get that 12.5. So I do like to write it out here again, that M is 12.5. And if we want to think about a meaning for that, that means $12.5, because dollars are on the top, per foot of fence. So it's $12.5 per foot. Okay, now that we've seen all these different cases, you should be able to complete the rest of the examples.